What's up, math scholars? Today is Radicals, day 5, and the very last homework of the year. We're not going to be done learning. We're going to be learning probability and stuff like that next week, but playing fun games like dice games and Who Wants to Be a Millionaire games and roulette, games that you can play with and do calculations with probability. But as far as homework assignments are concerned, tonight is it, and then tomorrow is a review, and Friday's a quiz, and I believe that'll be the last quiz of the year. So that's awesome. We might be doing mini quizzes with the probability section, but no actual formal quizzes from here on out. Awesome. Who's excited? Summer, summer, summer. I'm excited for summer. All right, we're doing more with rationalizing today. The problems are just going to get slightly harder. There'll be some foiling today. There'll be some distributing today that we never had to deal with yesterday. All right, so the true goal is the same, and that is our goal is getting all those radicals out of the denominators. So in this one, we'll use pretty much the same strategy as yesterday. We'll be multiplying the top and bottom by radical 3. But here's where life gets harder. See how our numerator is 2 terms? Anytime you have a numerator or a denominator with 2 terms, you have to put it in parentheses, because there'll be some distributing that will have to happen when we multiply by the radical 3. This radical 3 will need to get multiplied by the radical 2 to give you radical 6, but it will also need multiplied by the negative 1 to give you negative 1 radical 3. And that 1 could technically be invisible right there if you would like. Now on the bottom, radical 3 and radical 3 give you that radical 9. If you don't want to write that there, you could just realize the answer is 3. But that would be your final answer. There's nothing that can simplify. You might think these two could subtract, but they cannot, since the radicals don't match. They are unlike terms. That's about as simplified as you can get. If you want to do anything at all, you could maybe erase the 1, because it could be invisible. Okay? Questions on the first one? A little bit distributing. All right, let's try this one. Move it down a little bit. Whenever I see a number as big as radical 21, I think, could I break someone out of jail with that? What do you guys think? Could I break somebody out of jail with a 21? It'd be 7 times 3, and that'd be it. So nobody can break out, unfortunately. So we're going to go ahead and rationalize like we did yesterday. We'll put a square root of 21 here. A square root of 21 here. Again, this numerator has 2 terms. You're going to want to use your parentheses. Grab your calculators. These numbers are about to get a little bit big. On the bottom, I would have 2. That 2 is still going to live there. But the radical 21 and the radical 21 would give me the square root of 441, which the square root of 441 is 21. So you'll have a 2 in the bottom, and a multiply sign, and a 21 in the bottom. I think my final answer in the bottom will be 42. We okay on the bottom? The top's going to be a little bit harder. The top's where we'll have to distribute. Negative 3 times radical 21 is negative 3 radical 21. And then these are both in radicals, so I actually can do the 7 times 21 in the calculator. It will be a negative radical 147. Now that's a pretty big number, so we probably would want to explore if anybody could break out of jail at that point. Negative out front, and then radical 147. So down here you have some space. Let's do some experimenting with this 147. It's definitely 21 times 7. And then 21 is 3 times 7. So sure thing, look at that. We can break our 7s out of jail. So 7 out front, 3 in jail. 7 out front, 3 in jail. That's my final answer. That negative 3 radical 21 remains unchanged, but we have a minus sign and then a 7 radical 3. The answers end up looking a little bit weird. All right, this slide just talks about how if you rationalize something that has 2 terms in the denominator, how you would need to use a conjugate. So I'm having the students write down what a conjugate is. It's an expression that has the opposite sign as the original, And then while you guys are writing, let me give you an example of a problem that would need the use of conjugates. 5 over radical 3 plus 7. That would definitely require the use of conjugates because there's 2 terms in the denominator. So once you're done writing down what a conjugate is, we'll try this problem. This will be our next example. So basically, just multiplying by a radical 3 here and a radical 3 here won't make all the radicals disappear from the bottom because it would create some distributing. You'd get a 7 radical 3 with a 9, and all the radicals won't be gone. So what we do is we use what's called a conjugate. We're going to put the conjugate here and here. And you notice I'm putting a lot of parentheses because I now need to group things together with other terms. This denominator needs grouped. So the conjugate of radical 3 plus 7 is radical 3 minus 7. And whatever you do on the bottom, you got to do on the top as well, just like yesterday. So that's going to be our setup. Alright, we're actually going to start with the top because it will be easier than the bottom, believe it or not. 5 times radical 3 would be 5 radical 3. 5 times negative 7 would be negative 35. And now let's talk about the bottom. The bottom is a foiling problem. There's no doubt about it. First, outside, inside, last. But I have some good news for you. The outers and the inners would actually add up to 0 with conjugates. Because this would be a negative 7 radical 3, and this would be a positive radical 7 radical 3. And they would go away. So we really only do our matchups of our first terms and our last terms. So radical 3 and radical 3 is radical 9. Positive 7, negative 7 is negative 49. And I think at this point, all we're going to do is square root that 9, which is 3, and do 3 minus 49, which is negative 46. The numerator was pretty good the way he was, so I'm just going to leave it. 5 radical 3 minus 35. That's what I would call a more difficult problem. It's just a lot more work. It takes a while. Okay. Thanks, oops. All right, here's our next one. We are going to use a conjugate. The reason being is our denominator is 2 terms. That's why. The conjugate we're going to use is 5 minus radical 3. That's a 5 minus radical 3. I don't know why my board wrote it so terribly. Okay, we'll start in the top. Radical 6 and 5. So 5 is not in jail and 6 is. We just kind of nestled them beside each other like that. They can't really make up 30 or anything like that. Just one's in the radical, one's not. Now, a radical 6 with a negative radical 3, that can be a negative radical 18. Pretty sure we can get somebody to break out of jail there, so we'll have to simplify that down before we finish the problem. In the bottom, 5 and 5 is our 25. And then radical 3 with negative radical 3 is that negative radical 9. Now, if you don't even want to bother with that step, I know Sandy was like, you can just skip that step. You can just make that 3 if you want. So I think my denominator is going to be a 22. My numerator, that 5 radical 6, he's fine. But let's take that radical 18 and see if we can write it a little bit more simplified. It's 9 times 2 and 3 times 3. So we can definitely get someone out of jail. So 3 out front, 2 in jail. A negative sign here. 3 out front, 2 in jail. Yep.
Why can't you just do the, like, multiplying both by radical 3 and then...
Here's why. Let me pause it for a second. Everyone said they're way too tired for board buddies, so I'm just going to make them try this one at their own desk. And go. Sorry, we are using the conjugate. I thought that was a fun word, but not as fun as the word asymptote. Have you guys ever heard of asymptotes? They're giving me funny looks. Asymptote. It's an Algebra 2 word. You'll learn it someday. Okay, so the conjugate you're using is 2 plus radical 5. On the bottom, you only have to partner your first with your last, so it's 4 minus radical 25, which is just 4 minus 5, of course. And what does 4 minus 5 equal? Just write it there now. -1. So if you got -1 in your denominator, at least you're on the right track. Now in the numerator, this times this will be 6, and this times this will be 3 radical 5. Okay. So it's 6 plus 3 radical 5 over -1. You absolutely could leave it like that. I want to talk about what a math scholar would do. A true math scholar would probably do 6 divided by -1, get -6, and then do +3 divided by -1 and get -3. So that's just totally optional. That's probably what, like, you know, the back of the book would put it in. The back of the book would put the answers in and stuff. Yeah.
I have a lot of questions.
Oh, sure.
I put
All right, we're going to have this one be our last problem. We're going to do it together because it is a little bit harder. Yes or no, do you think we need a conjugate? Yes, we had a conversation about if your denominator is 2 terms, you need a conjugate. We definitely have 2 terms. We have that plus sign separating the terms. Here's what makes it harder. Our numerator is also 2 terms. So it's going to require a lot more foiling to get the answer. Okay, so, excuse me. All right. You have to actually group the top and bottom, because the top and bottom are both 2 terms. What conjugate do you think we should put here and here in our new created blank spaces? -4 minus radical 3. -4 minus radical 3. Alright, let's start on the bottom. Since the bottom are conjugates, we get to do the abbreviated FOIL. So this whole abbreviated FOIL thing we can only use when we're doing it with conjugates. -4 times -4 is +16. And positive rad 3 with negative rad 3 is negative radical 9. And of course, the square root of 9 equals 3. And then 16 minus 3 equals 13. So I think 13 is my final denominator. All right, the numerator. I've got some terrible news. This numerator, 5 plus radical 3, and this numerator, -4 minus radical 3, are not conjugates of one another. I know one has a plus and one has a minus, and these are both 3s, but these are both not 5s. So we have to do the whole entire FOIL process. Yuckies. It will survive, but it won't be fun. 5 times -4 is -20. 5 times negative radical 3, I would write as -5 radical 3. I can already tell I'm going to run out of space. So I'm going to actually just move this down to the second line. Okay. I have a problem of writing too big. All right, my next FOIL would be the inside with the inside. So that would be a -4 radical 3. And then last would be my last with my last, negative radical 9. Which again, that negative radical 9 is actually just -3. The square root of 9 equals 3. Right. So now I do have a couple like terms. These two guys with the green check marks, they are like terms. They can give me a -23. And these two guys with blue check marks, they are like terms. And this is tricky. If you have -5 radical 3 and you subtract off 4 radical 3, that's a -9 radical 3. It's almost like those x's, you know, you can combine them. And that's about as hard as it's going to get when you have a numerator and denominator with both 2 terms. Thanks to everybody for watching the video. The homework last night, Gabe already has it in front of his desk. It's the back of the day 4. It's day 5. Bunch of radicals. Your last homework of the year, so pour your heart and soul in that puppy. Kind of a sad day, almost. Ta-ta!